So that's the 20th century management thinking that does not have place in 21st century. And this also relates to the type of culture and mindset. So we need to automate to create a capacity for our teams and for ourselves to innovate and deliver products better. The third element is the lean processes, so transparency and visibility that allow for identification and removal of the bottlenecks, which helps with the efficiencies and delivery. The fourth one is measurement, short iterative delivery, hypothesis testing, frequent evaluation. Are we on the right track? And the fifth one is the recovery. So ability to identify problems in production and recover quickly. So we are lucky today because we've got two speakers that between themselves are going to cover all 5 areas. So with this, I'm going to hand over to Alison, who will moderate today's session. Thank you. Alison, over to you.
Thanks, Andre. And my name's Alison Bennett, for anyone who hasn't, who I haven't met before at our meetup. So I'd like to introduce our first presenter this evening. Her name is Christine Ozeroff. Christine is currently working towards establishing a learning culture as the Innovation and Technology Learning Manager at WorkSafe BC. And tonight, Christine will be discussing something that's close to all of our hearts if we work in DevOps, and that is how a relentless learning culture is the cornerstone for DevOps. So welcome, Christine.
Thank you, Alison. I'm just going to share my screen now.
If folks want to ask questions, feel free to use the Zoom chat to ask questions. And sorry, did you want to address the whole question thing, Alison, first?
Yeah, sure. If anyone would like to post questions in the chat, please do so. We will have our normal Q&A after Christine presents and after Chris, our second speaker, presents. So you can ask your questions live to them as well, or post them in the chat, and we can help to moderate that when Christine's finished her presentation.
Okay, so I'm going to ask the 2 questions that everybody always seems to ask when they do these things. Can you hear me?
Yes.
Okay, yes. And can you see my screen?
Yes,
we can.
Excellent. Okay, so thank you for that warm welcome, Alison. I just want to let you know that this presentation is very dear to me. Basically sharing with you my experiences over the past 20 years from training, being a teacher, being an instructor, all the things that I've been involved in with the WorkSafe BC education, training, and learning. And what I'm going to talk about right now is what happens when you're not learning. You'll see by this comic here that there's 2 T-Rexes, and they obviously missed the boat. One point in time, they ruled the earth and were very big and strong, obviously, but they eventually became extinct. So some of the things that happen when you're not learning is, you basically, if you turn around and you say, I know it all, it really signals that you've stopped learning because you feel like you have all that knowledge. When you're a terminology king, you may be using big words, you maybe sound really intelligent, but sometimes it may not necessarily be accurate with the actual knowledge that holds solid beneath those terms. don't imitate the big giants. So, you can see here that there's the two T-Rexes. If we imitated those two big giants, we'd probably be doing a lot of roaring. And, where does that leave us when we do a whole bunch of roaring? Probably in a bad state, in a large fight of some sort. And we also have here, don't quote just the big books. So just the books, I should say. What I mean by that is, a lot of the books now potentially could be obsolete. They may no longer be relevant. It's probably best to look at the principles. Those are the things that would probably stand true. And, we don't want to be stuck in those ways and not learning, not evolving. So history makes it evident. We have been learning from Mother Nature throughout our evolution. We have here mammals equals evolution. Every step of the way we are learning. And at one point, stones were a critical tool. They allowed us to communicate, and now we use cell phones. Who can't stand a day without being their cell phone on their side? We used to build things, and I think we still do build things actually just for fun. This is, when we were a child, you get to have fun with the building blocks, hang out in the sandbox, build some sandcastles. We moved on from that and took a look at safety, life, and comfort. Here, we looked at what are the ways that we can stay safe, not hurt ourselves, and develop things to prevent injuries. We looked at, comfort in terms of taking raw food. We learned how to cook and make things flavorful. And now we have the rate of change. It's impossible almost to keep up. And of course, that rate of change, it never stops. Change is unstoppable. And one point, we used to have bull carts. They were the envy of everyone at the time because they got us to places where we needed to go, where we wanted to be, and at an efficient pace. Now we've evolved and become, fans of Formula One race cars. And who doesn't want a Formula One race car? Learning equals evolution. So, this is the key here. We have learned throughout our history. We started from these microscopic beings into mammals, and every creature learned and adopted along the way, just like we do. Learning from our ancestors, learning from our experiences. Humans now, you could say, dominate the planet. And, keeping the saw sharpened is key. The example I give there is, if you have a saw, you're cutting down a tree, it may be really efficient at the time and really sharp, it works really well. But if you keep coming back in the current state, eventually it's going to be a long time before you can cut that tree down. It becomes dull. So to stay efficient, sharp, and ahead of the curve, you want to keep that saw sharpened and more efficient in terms of your time, of course. So where did we go from there? We looked at the water. Where there's water, there's flow, it's energy, it's clean, and civilizations evolved around the water. Our economies were built around the water, and we evolved from simple boats to cruisers. And you could say, in a way, we learned the ways of the water. And where did we go from there? We went to the air. The first flight that took place was in December 17th, 1903. And the next evolution was, you can look at the span, this is pre-COVID, mind you, 3,000 planes landed in New York City on a single day. It's amazing to think about that. The efficiency and the optimization that happened to make that is incredible. We've got expanding minds, and when you look at how it's changed our life, before I think COVID, you know, people wouldn't think twice about getting on a plane and traveling to a warmer climate, to Europe, to another city, another part of the world. It's just become part of our lives. And in a way, you can say that we learned the ways of the air, but that wasn't enough. We had to take it further. We learned about space. A space you could call the next frontier. We landed on the moon, an incredible feat. And now we have satellites, and everything that has a GPS is connected to the satellites. Your smartwatch, your smartphones, everything, you know, just even telling me the heartbeat that I have on my smartwatch it's fascinating. We now have Elon Musk, who has landed rockets with the boosters intact. Who would think of that? There's now the space station, which is what I would say is a new normal. When we fly up into space, where do we go? We go to the space station and learn even more. We've learned the ways of space. And from there, where do we go? The internet. It's connected to everything. Messages are delivered seamlessly. We have a flow of energy that causes a disruption every 5 years and is getting even faster. Sony was one of the first to disrupt their own product. They quickly realized that their competitors were copying them. So by disrupting their own product, making it newer, making it better, it built this ecosystem where people want and need to get the latest and newest of everything. You know, businesses have learned how to evolve that way too. There's Amazon, there's Google. They will constantly be learning. Otherwise, they're not evolving. And they obviously are quite successful in keeping that urge for people to learn and know more and get the best and biggest of all. Now what do we have? We go beyond the stars. Who knows what's going to happen next? We have the Internet of Things, artificial intelligence. Maybe one day we may have a school where we want to send our kids to on the moon. We look at food, our lifespan, human culture. You know, this all relates to the fact that, you know, we learn and then we pass on that information just like a relay. It's very similar to a DevOps loop. We share, we learn, we pass it on. We make mistakes along the way, and we learn from that as well. There's this immense urge for people to learn, and I think honestly it's going to be limitless. I say here though, I put a little comment there about it's limitless, but it's not like a bottomless can of Coke. You don't want to expand the wrong way in a sense. You want to expand in a healthy way. We have what is called the new flow. So we're only just getting started. When we learn, we adapt and we act. This is something that's just built into DevOps. There's also a paradox there too, that great minds are not bookish, yet they're the ones who wrote the books. So it is a bit of a paradox there. Trial and error, we make mistakes, we learn from those mistakes, it's implied. And essential services, this is just the way that we need to evolve and we need to grow. It's amazing, I think, the things that we can do, given even our current state with COVID. People are learning and adopting, they're building things, they're inventing things, they're making mistakes and learning. So this is what I wanted to pass on to you, that keep calm and do the impossible. Thank you, everybody.
Thank you, Christine. You've given us a lot of food for thought there, and I'm going to open it up to the floor now. Would anyone like to ask Christine some questions?
Yep. Matt is over there.
You can do it in chat or directly. Sorry, Andre?
No, Matt actually has his hands up, so.
Okay. Go ahead, Matt. No?
You're on mute, Matt.
No, Matt was just clapping.
Oh, I
He
see.
says. Okay. And we have a few great presentations, Christine. And any questions for Christine?
Yeah, if you want to ask a question, please unmute yourself and go ahead straight.
Go ahead. Yeah.
Hey, Christine, thank you for that great presentation. I had a question regarding, you talked about failure, and I think, that can be really tricky for a lot of organizations and a lot of folks. I think it's really important to celebrate failure. A favorite quote that I often recall is, failure is the negative space around success. And that is attributed to the folks at Pixar. So in other words, you need to fail to succeed. So I would love to hear from you how you curate failure.
Well, I think failure, obviously it starts with a mindset. There has to be a shift there in order for people to evolve. I think, you start at the grassroots, give some very basic examples, and build your success based on that. It's a bit difficult to grasp that mindset, but I think over time people will understand. Certainly that's the case here in 100 and I think 30-year-old company of WorkSafe BC. We're making the shift. It doesn't happen overnight, that's for sure. Andre could probably speak more to that than me, but it takes a lot of energy and a lot of determination to build that. But that's where I come from anyway.
Any other questions for Christine?
Maybe just a comment that on what Mark was saying. I think the key about that failure is the opportunity to learn from that failure, right? And not only for the individual who might have encountered that failure, but also like whole groups can also learn from that. In our QA team, there was an example where some of the automated scripts had some problems in them, and then we can leverage that and bring in some people to help explain the right way of doing it. And it doesn't have to be just for that individual, but for the whole team. So that's something that we can organize in communities of practice, for example. So definitely one small thing can turn into a big learning opportunity for the entire team.
Absolutely. If I can add to this, there is no such a thing as failure. Failure happens only if you repeat the same thing 3 times or more. Then it's a failure. If it's less than 3 times, that means that you're learning. And it's like with walking. You're going to fall, but you get up. I don't remember who said this, but what is the art is in getting up. In the moment we cannot get up, that's a failure. And we are all facing these problems. DevOps is all about solving problems. So that's the exciting part of the life.
And I like Sangeeta's comment, failure is the first attempt at succeeding. So, very true. Any other questions for Christine?
Yeah, I would just follow up on my earlier question about selling failure. How do you sell failure within the organization so that you can get the appropriate resources and time to really sink your teeth into that failure and leverage all the opportunity and the value that it brings to the team. So instead of it being seen as like, we're in the tar pits here, we're trapped, or we're moving too slowly, it's like, wow, okay, well, we're really extracting the maximum amount of value from this quote unquote failure.
I don't know necessarily that you would want to focus it on as or focus the attention on it being a failure, but embracing what it is that you've learned from it, and how do you move forward from there. I think it's the key is looking at it from the opposite angle and really fostering that and making it happen. I think that when you're working at that on the floor, I guess you could say, it's hard to see beyond that. But I think, if you can just try and that's been my experience anyway, is that, you know, when you're looking at it from a failure rate, at where's the beauty in that, right? Where is it that you're seeing the positive statements in that? If you look at it as embracing the change, embracing what you've learned, then I think that you have much more to accomplish. I think that's just where we've been in terms of the things that we've done here in DevOps at WorkSafe anyway. It's just a shift in your mindset. It's not an easy thing to do, of course, right? You have to have some buy-in from those that you work with, both above and below. It's a cooperative event.
Yeah, if I can add to this, it's really about the foundation of that is creating a culture of safety. People can safely fail, right? I mean, we don't want that the production system goes down, but we should never penalize, or should not have a system, organizational system, that penalize people for trying something and failing. I mean, without trying, right, that there is no success. We cannot innovate. We cannot do anything without failing. And that's the natural part of life. And within organizations, managers and others need to really understand that. So that's why this is so hard, because, you know, 20th century leadership type was, you know, Taylorism. You know, Taylor was treating people as machines. You fail, you're fired. That's not what it is today, right? Today, the organizations are not about software, are not about applications, are not about, you know, physical servers, or it's about people. That's where the biggest assets of your organizations are. So it requires the cultural shift. And as Christine mentioned, on the top and in the bottom, it's a huge endeavor.
There's some interesting comments in the chat. Christine is staying with us for the presentation this evening, so we will have another opportunity towards the end of the evening for another Q&A. So if you do have any additional questions that you'd like to ask Christine, you can always pop them in the chat, or you can ask her again a little bit later on. So if there's nothing else at this time, I wanted to thank you, Christine, for a lovely presentation, wonderful insights and things for us all to think about. So thank you very much.
Thank you, everyone. Really looking forward to hearing Splunk's presentation too.
Thank you for that segue. So yes. I wanted to, before I introduce our second speaker this evening, I wanted to introduce Jerry DaCosta from Splunk. Jerry's the senior sales engineer, and we've got a few people from Splunk with us tonight, and Jerry's going to introduce the team.
Yes, all right. Well, thank you so much. Thank you, Christine, for that great presentation. I just wanted to, before I start off, I just wanted to give everyone a bit of a reminder that if you have any questions for Chris as he's making the presentation here, please feel free to use the Zoom channel or chat, sorry, to ask your questions. We have a team of Splunk folks that are here that are going to, in addition to myself, that are going to, you know, capture some of those questions, making sure that we you know, keep them together. And then when we get to the question and answer period, we'll make sure that we address every single one of those questions. So feel free, and if we can answer them, you know, on the Zoom chat right there with the team of folks that we have on here, we will do so as well. But, you know, for the most part, just save your questions until the QA, or just answer or ask them in the chat, and we'll get to them. So, all right. Well, so a little bit about me. I already had a bit of a brief intro, but my name is Jerry DaCosta. I'm a senior solutions engineer with Splunk. I am based here in Vancouver. And so me in a nutshell. So my life came from being in the Oracle DBA world. I was an Oracle DBA for a startup company in Calgary, as a matter of fact. And I had to make sure that that Oracle database needed to perform as a real-time transaction database, as well as a data warehouse. So, you know, I had to balance this stuff on, you know, trying to make sure that that database performed. And as time went on, I went through, you know, infrastructure consulting, and data availability. And you know, as it turns out, I'm right back in the world of data here at Splunk. So I am your advocate, your technical contact and conduit for all things Splunk here in Vancouver. So if you have any questions, technical questions, or anything like that, please feel free to email me. I'll make sure to post my email address in the chat so that you guys can have it and use it at any time. And if you have any further questions or any further information you'd like, just feel free to email me. So with that, if we go to the next slide. Okay, so this is our agenda today, and I'm not going to steal Chris's thunder by talking to these points at all. But what I will say is that Chris has got an amazing demo of Splunk that will very much address every single one of these points. And in actuality, I'm sure that he's going to tie in many of the things that Christine talked about actually into the presentation. But what we do hope that we achieve for you in this presentation is we hope that we can get you to feel that how we can make your lives better as developers or as folks that are part of the entire DevOps pipeline process, and feel excited about the possibility of what it is that you can do with Splunk and SignalFx. Okay, next slide. So for those folks that are new to Splunk and don't know who Splunk is, I just wanted to give a little bit of background. So who is Splunk, or what is Splunk? So Splunk was founded in 2003. And the creation of Splunk was actually the result of our founders back, you know, in the Y2K era and Y2K times. I don't know how many of you are old enough to remember that, but I certainly do. But back in that time, our founders were talking to our customers during Y2K about some of their key challenges. And their biggest challenges that their customers talked about was trying to interpret all these machine logs and data that was being created by devices like Cisco routers, Solaris Unix servers, all these different types of devices. And the quote that they remembered when they came back from their customers was one quote by one of them. They said, "I wish I had a Google-like service to search our logs." And thus, this is how Splunk was born. So if we fast forward for many years, and I'm just scanning through a lot here. So if I fast forward through many years, folks outside of Splunk started to realize the power of the platform. So people outside of IT, outside of the typical users that were using Splunk, started to realize the power of the platform to perform these really impressive correlations on all kinds of data, not just machine data, but all kinds of data, whether they came in from, you know, user input or what have you. There was a whole bunch of abilities to correlate, which led us to architecting Splunk to being that data to everything platform. So what does that mean? It means that we want to our customers to bring data to every question, every decision, and every action. So now, fast forward again a little bit to September 2019, SignalFx joins the Splunk family and adds additional capabilities around application observability, which helps us perform deeper correlations for even greater insights, like, for example, within the DevOps pipeline, which is exactly what Chris is going to be talking about. Next slide. Okay, so here's, I just wanted to introduce you to their local Splunk team. Now, Sean Kilroy has been with Splunk for over 6 or 7 years. So many of you folks might already know Sean. Sean is part of the enterprise accounts, part of the field team. And we've got Chris Jacob, who is also here on the call. She's part of the field team as well, but she represents public sector. Next slide. Oh, and then we've got me here. Again, I'm your senior solutions architect, engineer, sorry. And we have Andre, and I'm not sure if Andre has been able to join us here today, but Andre is the guy that I go to when I have questions. So Andre is the consulting sales engineer. He has a wealth of knowledge on so many other different aspects of Splunk, of Kubernetes, of, you know, containers. So I go to Andre whenever I have questions. So feel free, I've pasted his email address, and of course these slides are going to be shared with you later on, so feel free to contact us if you have any sort of technical questions that you'd like to address. Next slide. And, you know, I just talked about SignalFx joining the Splunk family. Here we've got Sam Lee, who is also based out of Vancouver. Sam is your regional sales manager here for SignalFx. He is can answer any of the questions on the SignalFx side. And Andy Sales. Andy Sales also works in tag team with Sam right now in our region. And so Andy has a wealth of information on SignalFx and integration with Splunk and all of that. So next slide. Well, what we also have is Dan and Vivek. So Dan is part of another, part of the same region here in Western Canada, but he's part of the commercial team. So there are certain customers like FinTech and some other organizations here in the Vancouver area that Vivek and Dan service. So, you know, feel free to contact any one of us. We will make sure that we direct you to the right folks, but this is your local team and we are here and ready to support you. Next slide. Now, before I hand over the reins to Chris so he can introduce himself, I just wanted to make sure that I reminded everyone to stay with us till the end of the presentation to learn how you can make to enter a draw to win one of 2 available AirPod Pros. So, and actually there are some t-shirts that we're gonna throw in there as well, because as you know, I know you may not know, we're also a bit of a t-shirt company as well. So please stay with us till the very end and you'll learn about those details of how to enter the draw. And with that, I'll hand it off to you, Chris. Go ahead, Chris.
Thanks, Jerry. And as a part of that drawing, you're going to have to keep your ears clear and precise, because a few of the things that I'm going to be talking about are going to be a key part of entering that drawing. So just remember that. Well, thank you everybody for joining and having me here. I think it's important anytime somebody gets in front of you to talk that they have an opportunity to explain, you know, why should I be up here? And a big part of what Christine talked about is become a big aspect of my role. So my name is Chris Riley. I'm a DevOps advocate and developer relations at Splunk. What does that mean? Well, I'm sure you've heard of the advocacy role before. It's a role that's common in the tech space. For me, it means that I can still dabble in software development, even though I'm a bad coder, because I'm a bad coder turned advocate. One of the things that I've always loved doing is keeping current on the technology, but I was never amazing at the execution side of it. I started my career as a .NET developer, and then it progressed into SharePoint, Azure, and Office 365 development. And that's when I discovered it wasn't quite for me. I enjoyed talking about the technologies more than actually creating them myself. So I appreciate everybody coming. I see we even have some peers on the call. If you want to find out more about me and my podcast and just have conversations about DevOps in general, you can scan that QR code and it will get to my information. By no means am I the person to reach out to for all of your Splunk questions, however, but I'm always happy to continue the conversation about the topics we're going to talk about today and help people navigate the DevOps market, because it is a very fragmented and sometimes confusing market. So as Jerry said, data is, you know, key to what Splunk does, data to everything. And what we're going to talk about today is data to DevOps. Now, what I want to get across here at the beginning part before we get into the demos is how important data is to modern development. And a lot of times when we think about modern development, we only think about the building of the applications and don't spend as much time thinking about what it takes to maintain the velocity of building those applications. So when you look at the nature of companies today, pretty much every company finds themselves in a state of transformation. Now, they can be in one of 4 categories. They could be in retain and optimize, which is, you know, the monolithic data center. Oftentimes your servers have names and you personify them. And it's not infrastructure you want to touch. You set it, you forget it, it works, so let it go, right? To what's lift and shift, where we start to consider taking the infrastructure still in monolithic form and moving it to the cloud. So still a very infrastructure-centric, take those behemoths and let's cloudify them. But as companies take the next step, which is starting to break down those applications, this is where the move in the transformation to the cloud opens up a whole new set of complexities and variables. And we see that most companies are in more than one of these stages, but probably in the lift and shift and refactor stages at the same time. And then you have a lot of companies out there who are cloud native. Now, cloud native doesn't mean that your application started in the cloud necessarily. It means that not only are you leveraging cloud to build and deploy your application, you are also leveraging the modern architectures of applications. So that gets us to the next complexity of all of this. So not only is infrastructure changing, the nature of our applications are changing. What was the monolithic infrastructure where we would deploy code onto a server, and like I said, that server usually had a name. Now the servers are part of the applications. So the boundaries between applications and infrastructure are blurring. That also, the nature of these applications is changing so significantly that the velocity, the number of transactions, the complexity of the applications themselves are becoming more distributed and larger. So a typical organization will have 40 to 50 microservices. A lot of organizations will have thousands of microservices, and the unicorns of the world have tens of thousands of microservices. So managing that is a completely different challenge. I like to compare it to your 1998 Honda versus your 2020 Tesla. What you can do with those two cars are completely different. The Tesla has a lot more possibilities, a lot more technology. You can do a lot more with it. But also understanding what happens when something breaks in a Tesla is much more difficult than your 1998 Honda, which is your more monolithic application. So those challenges are exactly what we're talking about today. And if you look back, and I did a little survey on this about a year ago at the conversation of DevOps. What do people talk about when they talk about DevOps? Well, they talk about one critical component that Christine was bringing up, which is culture, which is an absolute imperative thing, and learning, which is an absolute imperative thing. The other thing that they talk about a lot is going fast. So velocity, release velocity, application velocity. What a lot of organizations have done is they've leveraged those approaches and strategies without thinking about what it takes to go fast, what it takes to make sure that that velocity is sustained. And in order to do that, it is all about DevOps, visibility, and metrics, and understanding what is going on in your delivery chain. And the bottom line is, because that increased velocity brings a new set of challenges. You may have heard of the term shift left, where more and more of the responsibilities of development are moving earlier in the delivery chain and sometimes fall in the laps of the developers themselves. You can't give your developers more work without giving them more tools to do their jobs and be more efficient. The other thing is, how do you know that going fast is working for your organization? Is it delivering value to your application? Is it delivering value to the bottom line? So it's surprising to me the number of organizations who don't have visibility and metrics into their pipeline's success, KPIs. How do they know when they've done well? I like to think of a delivery chain as an application in itself. It's the application of applications. It's something that is your customers of it are your developers, are your test engineers, are your DevOps engineers, and you are delivering this to them. So this app of apps also has an SLO or SLA, but SLO. And you have to measure it. You have to monitor it. You have to make sure that you have compliance and auditing. You have all the aspects that you have for your application as well for your delivery chain. And finally, the whole reason we do all of this is our customers. So when the pandemic started, we had to do remote education for my girls. We quickly signed up for a whole bunch of applications for education. One of the applications we signed up for is one of the most popular, and it is probably the best content. Maybe it is the best content. I don't know. What I do know is that their application did not satisfy my wife and Mai's expectations of a modern application. So we subscribed for a month and canceled and went to an application that was. So this is all about the customer. And really, when you think about what we are doing as developers, SREs, DevOps engineers, cloud architects, is working backwards from the customer. Previously, when we had monolithic infrastructure, our customer was the server. But now our customers are too demanding, and we have to move too quickly for that slow-moving response to be adequate. And now latency is the same as downtime. You can't just wait for your application to be down to address challenges going on with it. Latency is the downtime. So modern applications, modern users, and the velocity of these applications open up a new set of challenges in terms of DevOps in your environment. And the way we look at it is that we think about this from a very data-centric and data-driven DevOps point of view, which combines pipeline analytics and observability, both of which we're going to talk about right now and then demo, to give a comprehensive solution for development teams. And not only a solution that spans the entire development team, but a solution that spans those disparate organizations, those disparate silos. Could be security, could be IT ops, because security professionals and IT professionals oftentimes don't get visibility until production. And that doesn't allow them to do their job as good as they can. So data-driven DevOps gives you both depth and breadth across your delivery chain. Breadth is pipeline analytics. So this is going to be measuring telemetry from your tools, from your tests. It's going to make sure that your HashiVault, your Artifactory, whatever tool you're using is actually up and running, and your delivery chain can deliver code. Spinnaker is up and running, Jenkins is up and running, and you're going to be able to build KPIs around velocity and unplanned work, mean time to recovery, all of these metrics that are important for the team to know and communicate about success. And then depth is observability. So in observability, you're going to go from the complexities of distributed applications to answers of challenges, and then also to rapid incident response and the context that is needed in order to support and manage these applications in production. So starting with pipeline analytics, because I'm going to go over the entire spectrum of data-driven DevOps. Like I said, pipeline analytics is getting telemetry from your delivery chain and rolling that up in a meaningful way that the organization first knows that they can monitor and operate the delivery chain. So are your tools up and running? Second, create metrics of success. Know that you're actually, the fact that you're moving faster is not just creating more bugs, or that your vulnerability scanning process is actually reducing your vulnerabilities in production. And finally, it's compliance and audits. So understanding, is somebody pulling code that shouldn't be pulling code? Is there some sort of strange amount of access going on with your secrets tool? So this is all comes together for those three primary use cases. The developers are going to be on the metrics side. The DevOps engineers are going to be on the compliance and the operate side generally. And here is just some examples of how that rolls up. So you can use it for visualizing incidents and incident response. You can use it for rolling up data related to your testing in your test suites. Maybe it's Selenium testing. Maybe it's, just seeing the trends of your tests over time. And you can use it in the most comprehensive use case is around your CI/CD tools. So getting data from Jenkins and Spinnaker and seeing how your application releases are going, watching the movement of artifacts across your environment. So that is breadth across your delivery chain. Now let's talk depth. Depth comes in the form of observability. If you're a healthy curmudgeon like me and you hear a new term like observability, you probably roll your eyes and try to ignore it for a while, because that's what I do. I did it in the early days of DevOps 12 years ago. I was the one who said DevOps is just application lifecycle management. And now I'm one of the biggest champions of the DevOps. So observability is another new term. And let me make a pitch of why you should care about this term. For all the reasons I said before, infrastructure and application boundaries are blurring. Application velocity is going faster, transaction volume is higher, systems are more distributed. In the days of monitoring, we had servers. When a server broke, we would go to the log and we would do a process of discovery on our own to figure out what was going on with the infrastructure. And usually, we already knew the answer. Usually, it was the Billy Bob server, and on the Billy Bob server, you get a disk full error once a week. So what do? You restart it, or you clear the disk. You have a script that deals with it. It's pretty straightforward, 1998 Honda style, right? In modern applications, that doesn't work for a lot of reasons. The complexity is too much for a single network operations person, SRE, to navigate the system on their own to know where to go to find the problem. So identification of the problem is extremely difficult. That pull system of going directly to logs doesn't work. You need something to push to you. So because these challenges are different, you use a term to describe a new challenge and a new problem space. And once that problem space gets big enough, then the term adds a lot of value. And so that's my advice on how to adopt new terms. That's how I adopt new terms. Now, if you're really cool, you'll call it OLE or O11Y for the cool kids. And you will never catch me doing that in public unless I'm defining it for you like I am right now, or I'm having a conversation internally. Because unfortunately, our industry has a tendency to weaponize terminology that doesn't need to be overly complex. Observability is a new form of monitoring that addresses the new challenges we find in modern applications. It is a development and a deployment strategy first. It is an approach to monitoring applications second. And third, it is a set of tooling that makes that complexity easier to manage and operate. Now, why do I put them in that order? Well, you shouldn't always lead with your tooling. If you lead with your tools directly dictate how you can modernize your environment. It shouldn't be that way. You should be leveraging your tools in the best way you know how. I'll give you an example. There's a concept in traces called tagging. Tagging is not something a tool can tell you what tags to apply. You need to know as a subject matter expert in your application to be able to do that and apply those tags. So that is all a part of a strategy that has to be a part of observability as well. When do you need to consider observability? You need to consider observability when the infrastructure, configuration, and code boundaries are blurred, like they are microservices with containers, Kubernetes, how we deploy applications. We're not deploying artifacts anymore necessarily. I mean, most people are, but we're deploying containers as well, which is infrastructure. Sometimes we're deploying functions in serverless as well. When metrics and logs are not going to be enough, when metrics and logs are the last step, not the first step to solving problems. As applications are increasingly distributed and as they become stateless and ephemeral. So some containers live and die in minute time. Serverless functions live and die in millisecond time. You can't go, they don't have a state that you can go and refer to because it's already gone by the time that you go there. You need a system that can keep up with that. So this is when we really consider the approach of observability and the tools behind observability to address these challenges. Who's a part of that? Well, another big term out there, and this is actually came before observability, is the site reliability engineer. This is a term that came out of Google. I don't think it should be called site reliability engineer. I think it should be called service reliability engineer, because we are deploying and delivering services these days. The idea of the version number is still used to relate it to our repos, but we don't put version numbers on our applications necessarily as we work with our customers. We're delivering services. But in any case, the SRE is observability's best friend. And in a lot of ways, the SRE is the steward of observability practices within DevOps organizations. This is a photo of Jonathan. Jonathan is a SRE at Splunk on our Splunk Cloud team. And he told me, and he's taught me a lot about the practice of SRE, always be learning, right? SRE is about being customer success. What I learned from Jonathan is that you always work back from your customer. How you configure your observability tool is based on your customer and what your customer expects to see. What the SRE brings to an organization is both a strategy and a role. And it's all about modernizing the NOC, keeping pace with release velocity, keeping pace with our demands of our customers, and giving developers an operational peer, an operational partner. If your organization still uses or refers to it as a NOC, saying still uses not fair, the NOC approach worked really well for monolithic infrastructure. It was often driven by spreadsheets. You had somebody 24/7 staffed in a room. You had at least a video game, or it would be a video game if it was me, but sports video game on one screen, and then you have a whole bunch of dashboards all around you that you were monitoring your infrastructure. Largely focused on infrastructure, not so much focused on the application. And NOCs were tending to be very just purely operational, owned by IT. What we saw in the NOC is that they had two general approaches when there was an incident. First is a spray and pray approach, where you email everybody and hope that somebody picks it up, or multiple people picks it up, and they can address the problem. Or lazy mobilization, which I think is more common than not, which is you always call that one person, Christine, because Christine fixes everything because she's up to date on all the DevOps. So that's not fair to Christine, because that's a key individual in your team and she's going to get burnt out. So both of those are problematic. Some organizations will just rename their NOC SRE without changing their strategy. But true SRE comes with a new strategy and potentially a new role. But an organization can have SRE practices without the SRE role. I see it a lot. So in the SRE role, instead of being 100% infrastructure focused, you're looking at infrastructure and applications. You're a partner with the developers, not separate of them. You may organizationally belong to IT, but your developers are your peers. You are embedded in development teams. You also, in the SRE model, understand that anybody can be on call. Even product owners can be on call. Even CEOs of companies can be on call. You should be able to add anybody to your on-call schedule and rotations, no matter who they are. And so this model has been tremendously successful for organizations to relook at how they monitor and manage their modern applications. What we generally see SREs doing now is, instead of being the ones on call, they will usually be the owners of the on-call. So they will own on-call rotations and on-call schedules. They will be a part of operations, but they're largely stewarding the best practices of SRE across their teams and their development teams. They will partner with their developers to understand what metrics are necessary to properly manage and measure the services that the developers are building. And they will oftentimes be a part of deploy preparation. So if a new service is coming online, they will follow the checklist with the developers to make sure that that service is set up to be as observable as possible once it is in production. And they will help decide, you know, what type of metrics do you use? Are they let's, read, use? There's all sorts of them out there. And they're, you know, I know people want to believe that there's just one de facto set of metrics that everybody uses, but normally what we see is that at a high level, you have some standard metrics that are team-wide, but at a service level, you probably will have more than 3. You'll probably have 5 to 10 metrics that are specific to the service and supporting the contracts that service has with other services in the application. So this is how we see observability and the SRE role coming together. Now we get to all the way on the other side. We started with pipeline analytics, which is planning, building, deploying, to observability, making sure your applications are set up for success in production, to now being on call. And I'm sure we all love being on call. Some of you might be on call right now. And of course, I'm joking. I've seen on call destroy relationships. It is difficult. It is very, very difficult. I have been on call for part of my career and I didn't enjoy it. And it was in the days of the monolithic NOC era. And so I'm happy that I haven't had to be on call for modern applications yet, because the complexities, the nature of what can go wrong are much different. But the nature of the tooling has caught up, and that's really exciting. So what we see is that observability is what feeds via alerts and context into incident response tooling. Incident response is a very specific function. A lot of times we think that incidents are short-lived. They may be, but the mobilization and action and what has to happen to properly mobilize people, it is complex. It's not trivial. And then finally, once an incident is recorded, perhaps resolved, incident management is your system of record for tracking those. So back to my car analogy, your observability tool and your observability process is going to tell you something's wrong. That's like your engine light in your car. Then it's going to give you more context. It's going to tell you where exactly it thinks something's wrong. That's like you stepping out of your car, seeing smoke coming from the hood. All right, so now we have an incident. Now we know, you know, we've overheated, something bad's gone wrong, and we need to address it. I'm not a car expert, so I'm probably not the right person. The next step is incident response. So all of that context from what just happened with your automobile needs to be fed into an expert. That expert could be roadside assistance, comes up, helps you address what's going on. But maybe the issue is even bigger than they can handle, and they need to get even more help. So at that point, the incident response expands into finding the right people at the right time to solve the issue. They're going to take it into the shop. They're going to get even more context once they plug it into a computer and get diagnostic codes and know exactly what's going on. And then resolve the issue. All of that data is aggregated and ends up in something like Carfax, which is your system of record. That is equivalent to incident management. Now back to what I said before, the 1998 Honda versus the 2020 Tesla. 1998 Honda, feature limited, but runs great. And when something breaks, it's pretty clear what it is. So not that difficult to figure it out. The Tesla, a lot more things could go wrong with the Tesla, including software, which Kubernetes, microservices, but also all the physical things that can go wrong with it. So identifying what is wrong with a Tesla, so when you get the alert, what is wrong needs to come with much more context. That is akin to your modern microservices-based applications. So what we want to see in a good on-call and incident response process is that we reduce the amount of time it takes to acknowledge an incident, and obviously the amount of time it takes to remediate the incident, but also resolution, because we often forget that resolution is not just fixing the one problem. Resolution is making sure that everything is green, because these things cascade. And so even though one service started the issue, you have to wait for all of the services to catch up once it's resolved. So there's much more involved. What we've seen in reviewing with our customers, who I admit are already ahead of the curve when it comes to incident response and DevOps, is that an average response time to acknowledgement is 25 to 45 minutes. An average remediation to resolution is 6 hours and probably involves 8 people. The goal of having a good incident response strategy driven by observability is to level the curve, so that acknowledgement is less than 2 minutes and it takes less than 2 hours and 3 people to resolve the issue. So I know I've thrown a lot at you. And as you can tell, we're very passionate about data and data driving everything. And so now I want to align this with, where does that fit with Splunk? But to begin there, I want to let you know that we're going through this journey also. Right? Like I said, most companies are in multiple of the stages of transformation. And this makes us uniquely suited to be a partner in the transformation journey, the cloud transformation journey, and the application refactoring and cloud native transformation journey. And we ourselves have experienced lessons around how to build these applications and how to monitor them. And so a big part of how we handle our DevOps environments is we really empower our SREs. Our devs are on call for their code, where our SREs are not on call for the developer's code, but they are on call for some components of the application. But generally, most of the code, the people supporting that and who are on call are the devs. We also tier our metrics. So we have a level of metrics that is specifically for the broader group. Anybody can log in, see the dashboard, see the red metrics, understand what's going on, the health of the system. But once you go one layer deeper into the services, those metrics are unique. They're unique per service. They tend to be more than 3 to 5, they're 5 to 10. And they're unique to the service owners. And we also invest effort in measuring our entire SDLC. That's pipeline analytics. I know I'm throwing another term out there. SDLC is software development or software delivery chain. Same thing as pipeline analytics. And what that starts to look like when it aligns with products and personas is that at its core, we have Splunk's amazing technology, and we have SignalFx. Once we start to get into observability, we're really focusing on the SignalFx product and incident response as the VictorOps product. And you can see at the top here, the key element of this is that all the personas in the software delivery chain are addressed here. And we truly believe that we're uniquely suited to be a partner in both breadth and depth in the software delivery chain. So I said VictorOps is our incident response product. I'm going to do a demo of that. SignalFx being our flagship observability product, it's built for the cloud, is built for transformation, which means it is best suited to handle these modern applications. It is full fidelity. So all of the trace data comes in. All of the metrics come in. We're not throwing away data. This is absolutely critical once you start considering things like RUM and AI ops. You need that data to support those next level technologies. And we have SignalFx for infrastructure. We have SignalFx for application performance monitoring, and also this cool Kubernetes navigator tool that I'm going to show now. So before I just jump into showing, I want to make sure there wasn't anything crucial that I missed, because I saw a lot of flashing. Okay, looks like we got a lot of stuff we get to talk about after we are done with the demo. So resume. Okay, so I'm going to start with SignalFx. What you see in front of you is a standard dashboard you would expect for, you know, typical modern application. This is a shopping cart application. It's called Buttercup Games. If you've never heard of Buttercup, Buttercup is our mascot, the name of a pony, which is our mascot, and shows up a lot in our demos. So this is a Buttercup Games store, I guess. We have an API gateway, API front end, and most critical part of any store is your checkout and your payment processing. It is driven by, 8 services here and running on 3 separate containers. What we can see is the general state of the service and the system running right now. So everything's green, our latency is good, the number of requests being processed is good, our request time is good, everything seems good. Well, let's pretend it's Friday, and what better idea than to do a canary release on a Friday, right, in the afternoon from my mobile phone. So I'm going to go ahead and do a canary release. What you'll see here in a second on the right is that we're going to see an event. There wasn't a release that happened, and there we go, canary push by Chris. And then suddenly our services start to degrade. We see the containers at the bottom. We're going to start to run into issues. Our latency spikes, the number of requests we're processing tanks, and now we're in the red. And this is bad. So this is something we might have in a NOC. See that it's a really bad scenario. We see that there's some containers that are going live to hopefully address the issue. And we have problems. But fortunately, in this case, we've implemented an automatic rollback. So instead of needing to go into the firefight directly, the service was automatically rolled back to the previous version. And now we see the state going back to a more healthy condition. You'll see on the timeline that we have the events, exact events where the canary release was done and where the automatic rollback was done. We can see how that relates to the various containers that we have running and also the services here. Now, the important thing about a service maps are extremely useful in modern applications because as we know that the service that screams at you, the service that throws the error, is not necessarily the service that's actually broken, right? It could be something else. And in this case, because the API gateway drives everything, that's what's going to scream at us first. So we need the service map and we need the technology to tell us where the actual issue stops or starts in this case. And help us identify where the issue is actually going. Because you can imagine if I went and tried to find logs just on the API gateway service, that wouldn't get me very far because we'll find out in a second, that's not where the issue lied. So that was
Chris,
neat.
Just to ask you, that whole rollback process, was that an integration with the continuous integration and continuous deployment, environment?
So that actually was an integration done directly in Signal. So it wasn't Jenkins or Spinnaker in this case that drove that. It certainly could, but in this case, it was done via a webhook.
Awesome.
Directly from Signal. All right, so we did the auto resolve, and that's great, right? That's a lot of fun. It is something that certainly, as you look in the path of AI ops and auto remediation, something that organizations should consider as kind of a North Star in the direction you want to go to. And especially if you're doing blue to green deploys or canary releases, it's a very useful tool. But let's talk about a troubleshooting scenario where you need to deep dive. So I'm back at a different view of the service map of Buttercup Games because of Buttercup. And now here I can actually go into the services directly. And I can take this troubleshooting view. So just assume that we're live in an incident right now. You know, things would be a lot redder. These lines would be a lot redder if it was a live incident. But in this view, I get to that help, that assist to visually identify really what's going on. You know, it's probably the authorization gateway that's actually probably causing the problem, not your API gateway. What's also great about this is the dependencies. So I talked about a little bit earlier about keeping metrics at a service level. Services, especially like backend services or business logic, are going to have different metrics than front-end services. And that's called your contract. That's the relationship of one service to another service. You have incoming services and you have outgoing services. And you need to, as a service owner, you need to make sure that you're keeping that contract, you're delivering on those SLOs. And so this dependency map allows you to actually identify when there is a firefight, where those ins and outs are, to see the relationship of the services to each other and how they are impacting each other in an incident. And especially as sometimes these incidents cascade, that's the thing you want to prevent. So it makes it much easier for a human to go in and say, okay, now I understand what's going on with the services and where the issue really is lying. I can also go in and view just the dashboard for that specific service. So look at the red metrics for this service and understand, okay, I think this is where things are going wrong. Now give me the metrics specifically for this service so I can dive even deeper. I want to go back because, as you may know, in observability, we go beyond metrics into traces and spans. Traces are a key component to following a transaction as it enters your application and as it leaves your application. So we have these very comprehensive trace views, and you can do them based on specific user traces to look at how transactions are flowing, where they get hung up, how much time they're spending, are they meeting the P99 latency requirements for a particular transaction or endpoint. You have all that data here. And this is critical, again, to troubleshooting, but also understanding the nature of your system and making sure that you're delivering on your service level objectives and agreements. All right, so that is the application side. Now let's do a jump to infrastructure. I'm looking at some of these questions. There's a great questions and comments, but I already want to address them, so I'm going to stop looking. All right, so we have this great tool called the Kubernetes Navigator. The Kubernetes Navigator is a window, a view into your Kubernetes cluster and allows you to have a quick spot check health of the system, quickly identify, you know, if we have a serious issue here, it's going to be red. In this case, we have a memory pressure concern on one of these pods, and we can deep dive into them to inspect to see if this is really an issue, because a lot of times it's not. A lot of times you expect CPU or memory to spike in certain scenarios. But the nice thing about it is that it's all right there in front of you, quick visual to see what's going on with your Kubernetes environment. Okay, now the alerts come out of your observability tool, Signal has fired an alert, and it's become an incident inside your incident response tool. VictorOps is our incident response tool. And I'm going to start with showing VictorOps from the mobile perspective, because VictorOps was a mobile first incident response tool and later added the other functionality around the web. You can get alerts on your Apple Watch. You can acknowledge them from their watch. What VictorOps gives us is the ability to create schedules, rotations, but also give our developers to create the most efficient way to be on call. So let's say, for example, at nighttime, they always need to get a phone call first and then a text message, or another phone call probably. During working hours, maybe an email is fine, or a message inside of Teams or Slack. So you can set up the behavior of the system so that your team is as effective as possible, and it makes it as painless as possible. It's always painful to be on call. So there's that component of it. Once an incident comes in, and hopefully I have an incident here to actually show you. I know there was about 2 hours ago. I'm trying to find an unacknowledged incident. Maybe I'll go with the Nagios run. Once an incident comes in, remember that incidents are a combination of alerts. So an alert is just the service saying something broke. An incident is a combination of those alerts into we have a problem. So it's more comprehensive. And with that, you're going to get context related to the incident. And this is absolutely critical. So as I was scrolling down, I didn't find a Signal one. I'm going to try to do that here in a second. But SignalFx will give you a screenshot of the SignalFx dashboard and a link directly back to Signal to see what is going on. But this context is important to make sure that you can try to resolve the incident as quickly as possible. We also have this annotations. This is where a rules engine will actually apply to specific types of incidents. You can put run books, you can point to Confluence articles, you can have other tools here based on the incident to help whoever is on call resolve that incident faster. And then you have similar incidents. This is where we aggregate incidents of this type that have happened before so that you can review the audit trail of those incidents and it'll help you resolve it quicker. You may have noticed all of this is about resolving incidents faster. But let's say I acknowledge an incident and I'm not the right person. We also have this functionality backed by machine learning where we can give you recommended responders based on their history of responding to incidents and the actual resolution, but also if they're on call or not. It's not going to recommend people, or it does, but it's not going to suggest people that aren't currently on call. So all about this is all about the fight or flight scenario where you need everything in that mobilization to go as seamless as possible. And this integrates directly with Signal and the next integration point, which is getting the data from these incidents to address this idea of, okay, we've had a whole bunch of incidents in the last week. What is going on? What is our average mean time to recovery? What is the average number of incidents? What is our cost of downtime? What is the average amount of unplanned work? Because unplanned work is very dangerous, especially if your developers are the ones who are on call. This is all data that helps you take the next step, which is improving your system, not just solving, taking the next step to advance what you're doing, make sure that incidents of a certain type don't happen again, make sure you understand what your application velocity is doing to your environment. All right, so that was a high-level demo, and now I want to highlight some lessons we've learned. And if you're interested in finding any more information about these, we recently did 2 events, one around DevOps and open source, because we are very big in the open source arena, especially around open telemetry. And the other one is around best practices for DevOps. You can, we can share the links after, or you can Google both those events on our events page, and there's live recordings of all of this. The most recent one is very enlightening because it comes out from us. So Splunk doing Splunk, or Splunk on Splunk. What have we learned? And some of the lessons that we've learned is, first, data is the connective tissue across your entire software delivery chain, both the delivery chain itself and in observability. You should always work back from the data. So understand what you're going to do with the data before you start implementing the metrics, the dashboards, and the processes around it. Enable patterns. This was kind of an aha moment from one of our lead engineers who told me that I can't force everybody to use the processes and tools that we want them to do, but we can enable the proper patterns. And by enabling the proper patterns, the guardrails, then adoption happens naturally. Also, we believe devs should be on call for their code. I know some of you probably don't want to hear that and hope that that never happens, but you can't do that without giving them the tools to be successful at that. So we see that devs should be on call for their code and SREs be on call for third-party components and code. SREs own on-call schedules and rotations. They own service onboarding, so before new services make it in production. And this concept of layering your metrics. So having a high level metrics that anybody can understand. And then at the service level is where you get the detailed metrics and dashboards for that service. We also really like the idea of dojos and stewardship in general, because we talked about learning and culture and the nature of, their DevOps breaks into both principles and practices. The principles side of it is more difficult to get across without an element of stewardship in dojos. Finally, I want to leave you with some resources before we get to Q&A and the giveaway. The first is a blog post. Hopefully we can share these slides with you. The first is a blog post on how we do SRE. Second is a blog post on the modernization of the NOC. Another webinar on SRE and SRE strategies. And lastly, OpenTelemetry. If you haven't investigated the OpenTelemetry project, please do. It's an awesome open source project for getting data into your observability platform. We commit a lot of resources to this project because we really believe in that standardization so that your agents and your GDI, or getting data in, sorry, your collection of data from your tools does not dictate how you monitor them. All right. There was a lot of conversation going on. So how best to handle this?
Well, let's, oh, sorry, go ahead.
Thanks, Chris. Happy to hand over to you, Jerry, too, but thank you very much. Fantastic presentation and demo. Lots of comments initially about your jacket. Everyone wants your jacket.
It's become famous, and no, I won't tell you to get it. It's mine. Actually, no, I was the first one to do it, and now I know it's 2 people on the sales team who have it, so I need to change it up and add something new. But hopefully you notice the this as well.
Very nice. There was lots of comments, but there was a couple of specific questions as well, and one of them was from Mohammed. And a few people answered this, and interesting to see what your take is as well. What's the key difference between DevOps and SRE?
Yeah, so I saw this response and I love it. And I don't disagree with the responses that came up. So first I'm going to define DevOps because that's what we got to do, right? DevOps, and I actually do this, and it's annoying to people when I have the conversation when they say, let's talk about DevOps, and I'll go, what DevOps? Which DevOps? Because in my opinion, there's 2. There's DevOps, the principles, and DevOps, the practice, and they're very, very different. So DevOps, the practice, is a role. I mean, you can't argue that it's not a role. You can go and find job recs for DevOps engineers. What they do is very specific. They build the automation around the delivery chain. So they're working with Chef, Puppet, Jenkins, Spinnaker, Splunk. Their customers are the developers, and they are building a delivery chain for them to utilize. That's pretty cut and dry. Now the problem with that, contrasts that with DevOps the principles, which is not so cut and dry. It's a little more fluffy, which makes it frustrating, but you will always know when an organization has been successful at this. So that combines the culture, the methodologies, the idea, we talked about blameless, we talked about embracing failure. I don't even like using the term failure. I think that becomes very risky, but the idea that failure is going to happen no matter what, so let's get there quickly and have a method to resolve it. You know, it's about visibility. It's about working together. It even goes into one of my talks, which is neurodiversity. It's about leveraging the key talents of your team by allowing them to be as human as they possibly can. And that's something that's important to Splunk with our neurodiversity program, and something that when I've looked at any high-performing engineering team, they have embraced. And what's crazy about this is if you think about a company and you think about if you went to an engineering manager and you said, you know, did you hire the right talent? Of course they're going to say yes. Why would they say no? And I believe them. They're right. Their team is highly skilled at development and building applications. Then you go to a high performing, so that's a low performing, and you know by applications. You go to a high performing one, you ask the same question, the answer is exactly the same. So what makes those two teams different? And what makes them different is culture, how the team operates, how the team works together, and that they have both a bottom-up and a top-down understanding that DevOps is a set of principles and you're never done. There is no day that you've done the DevOps. I've seen some organizations implement DevOps in waterfall as a project, and it never works.
Okay,
Hi,
Chris. Okay, go ahead, please.
Hey, hi. This is Naveen. I'm a SRE with WorksABC. So I have a couple of questions. Mainly with context to the application insights, because currently, like at WorksABC, our main observability platform is like application insight. So my question is like, how like Splunk is better for like Azure native services, like. And as you mentioned, right, there is a like latency, the downtime, and we have seen like there is a couple of like latency between the like event happens and it become available in the application insights. So how does Splunk do better in that? And
Right.
Another question is like, if we want to move from application insights to Splunk, what all it takes?
Yes. So the latter part of that question, I think that would need more specific unpacking with your environment. There's a lot of untangling that has to happen when you talk about how you instrument your application, which is why OpenTelemetry is such an important project. But let's just start with the big umbrella. And the big umbrella is your management plane, which is the plane that you use, the technology you use to manage and operate your applications and your infrastructure should not be a part of your infrastructure, if that makes sense. So you shouldn't have a management plane that is embedded as a part of your infrastructure itself. It should be distinctly separate for all the obvious reasons. The first one is that, you know, if your cloud provider is also your monitoring tool, your management plane, and there's an issue there, then you've lost your ability to manage it. And you've lost a lot of the tools in your bag to take care of your applications in production. But the other reason is that hybrid cloud, multi-cloud is very common for organizations. And it's really hard to be hybrid and multi-cloud if you've locked yourself into a specific technology. So that's just a conceptual, that's a strategy standpoint. From a technology standpoint, my best answer is please come, let's try it. Let's try Signal and see if the latency meets your expectations. The other thing is that, you know, I can sit here and tell you that we have higher resolution and it's faster, and everybody's going to tell you that, right? But try it. Come and experience it for yourself. We are full fidelity. We maintain everything. We also have unlimited cardinality, which means all the metadata that comes with your traces and spans is there as well. These are all key aspects to having a resolution in your monitoring that is critical. And you know, the resolution, I will tell you, is faster, but I need you to see it for yourself. So reach out to Jerry and our peers there to figure that out.
Thank you, Chris.
We had another question while you were presenting SignalFx, and it was, what is the time period to pull the history metrics?
Well, so you set the time, if I understand it correctly, everything that we were looking at was in 15-minute intervals. So it's from real time to 15 minutes, if that makes sense. That's the window. You have control over that resolution. I don't know where it caps out. That's something that I should know, but I don't know what the span or how far back it goes. We keep all of the traces and spans. So any of the retention is based on, you know, your licensing and agreement with us, but that time interval was 15 minutes.
Perfect. In terms of, like, again, lots of great discussion. Congratulations and on a good presentation, Chris. And yeah, where do you get that jacket? I think everyone is burning to know. Where can you get that jacket?
Nope, it's a secret.
Oh, Chris!
It's a secret. I can't give up my sources. As I said before, I'll give it away. It was on Amazon. It actually Amazon. So that's crazy.
There you go.
I do see a lot of Splunk specific questions, specifically around Azure, which it was Azure App Insights is what I was talking about previously.
Yeah, that was actually sorry, Naveen was the one that asked that question on Zoom and then actually asked it in person. So yeah, I mean, if there's go ahead.
So the other thing I would say there is if you go to the Azure monitoring page and you click on partners, you see both Signal and Splunk. So we are partners. They acknowledge that, you know, the other thing, because I don't like throwing tools under the bus, so I'm going to try not to do that. But the other thing I will say is that SignalFx was built for observability, which means that traces and spans are there out of the box, and there's no special instrumentation that you have to do for it. But we do have instrumentation for .NET applications. We have auto instrumentation for .NET applications, and we do have integrations for Azure infrastructure, because I saw Azure show up there a few times. So I wanted to address that. Anything else specifically, you know, please, whoever is asking these questions, reach out and let's make sure we get the answers for you, the detailed answers.
Absolutely. Matt asks, is it possible to roll out a version gradually using data to see if there are any errors before a full rollout?
Matt, I don't know if you're there right now, and if you can, are you talking about Signal rollout or are you talking about application rollout? Because there's certainly a strategy for both.
Oh yeah, like an application, like before you hit, you know,
Deploy,
yeah, exactly.
Yeah. I would hope so. Yes. You know, the strategy there is, are you familiar with synthetics? And I didn't mention synthetics earlier. Synthetics is often the strategy for basically testing your application prior to rollout and seeing how it will respond to similar data. Now, there's controversy around that, because some people would say that there's no data like production data. So some people in the camp of blue-green deploys and canary releases say just put it out there and see what happens, and just make sure you can roll it back quickly. Most organizations aren't there, and that's fine. Synthetics is a great approach to addressing that.
The next question is, what is the recommended deployment platform for Splunk SignalFx to monitor, observe a multi-cloud hybrid cloud ecosystem?
Yeah. Yes. So again, it's a strategy, not an answer. There's a lot of answers in terms of tooling. The first strategy is making sure that you understand your stack really, really well. because without having a good information architecture around your existing multi-cloud and hybrid cloud stack, hybrid cloud especially. So, and let me define those quickly. Hybrid cloud means two different types of cloud, on-prem, public. Multi-cloud usually means public, two public clouds connected together, or you can shift your entire application from one public cloud to another public cloud, which SignalFx is actually set up to do. So you need to understand your stack really well. One way to do that is a good incident response tool. I would recommend VictorOps because it forces you to connect the dots. By virtue of connecting the dots as a part of your strategy, you get more visibility into the two disparate systems, what's on the on-prem, what's in the cloud. Then that allows you to take the next step, and which is observability and infrastructure monitoring. Great thing about SignalFx is in addition to APM and observability, you have your traditional infrastructure monitoring as well. So it is one platform that can work together. If for your on-prem, you're really on-prem, like you have a DMZ and that thing is locked down, then you can consider Splunk on-prem technologies in addition to Signal for your cloud native and your cloud applications.
Awesome. Vera asks, are we providing Splunk as a service in Azure? Now, I'm assuming, Vera, when you say that, you mean Splunk or Splunk SignalFx APM as a service in Azure. Is that fair? Vera, if there's a way you could let us know if that's what you mean, like SignalFx as a service within Azure.
So Signal runs outside of your cloud provider. And like I said, as a best practice, that is something that you would tend to want to do. You want your management plane to be separate from, and this is true with VictorOps, from your infrastructure that it's monitoring, what it's actually watching. But there's integrations with both. So in terms of getting data from AWS, GCP, and Azure, out-of-the-box integrations to do that. So it looks like Sam, we probably should just pause for a second, Jerry, and just call out this giveaway.
Yeah, exactly. I was just going to do that.
Make sure you have grabbed this link because this is how you get into your chance to win the 2 available AirPods.
So what we're going to do is we're going to take names and we're going to make a draw for 22 folks. The first 2 folks of the draw will win the AirPod Pros. The next 20 will get t-shirts, available Splunk t-shirts. And so we will work with you and connect with you for those folks that win any t-shirts and the AirPods. We will connect with you after the fact, after you've sort of registered for the draw, to arrange a time for delivery of these t-shirts and AirPods. So please, go to the URL down below. If you type it in, I guess Sam has also put it into the chat. So all you have to do is click it, enter your name and company, and then answer some 2 questions. Could it be that folks are having problems with the questions?
Let me give some
You can
hints.
Google them too, by the way.
So the 2 are hoel, which relates to a term that we've thrown around here more than enough times. And the second one is to our mascot, which was the same name as the application that I was doing the demo on. So if that's what's holding you back, hopefully that helps.
Yeah, exactly. You could totally Google the answers and it will show up right there. So Splunk's mascot into Google will tell you exactly the answer. And if you Google hoel, O11Y, and you will
O11Y.
Yeah, O11Y. You will find out what the answer is. So don't let that stop you.
That's what we get for trying to make it too fun.
Yeah, exactly. Boy, yes. So please register. And sorry, if you want to just go to the next slide very quickly, and then we can come back to this. I wanted to also talk about, for the folks here that we've got, I know we're a little bit over time, but please join us for .conf 20. This is our user conference that we have every year. This year, it's going to be a virtual event because of obvious circumstances, but what that means is that it's free. It means that you don't have to pay for travel or tickets or anything. You can join for free and attend any one of the conferences. And there are a ton of observability sessions available. Chris is actually, speaking at one as well, but we've got a ton of great sessions there that you can look at. So please register for .conf. You won't regret it. It's actually a very, very incredible conference. I can't wait to actually join. It'll be my first one, so I can't wait. So yes, and so anyway, we'll just flip back to the previous slide. And you know what? Thank you, folks. Thank you, Andre. Thank you, everyone, for hosting us here today. Thank you, Allison. Sorry, and Christine. Thank you for the great presentation as well. I'll just hand it off to you guys now.
Thank you.
Thank you very much. Fantastic presentations for both of you. Many thanks to both of you, Christine, Chris, and entire Splunk team. So I learned a lot, and I'm definitely interested in following on some of these items. Now we're going to wrap up in a moment, although we are not going to close this session. So if you would like to chat with Chris or Christine or other people from Splunk, you still have an opportunity to do this. But at this point, I would like to wrap up. And so just want to say that we are going to have a next session in November. So please watch your emails and invitations. We are always open for speakers. So if you would like to share your experience about implementation practices or tools related to DevOps, please contact Alison or myself. And thank you very much for joining us tonight, and see you in November. Thank you.
Great, thank you.
So if anybody else got any questions for the next couple of minutes, please go ahead. You can still continue with questions.